So let's take a look at the actual definition of a partial derivative. If f is a function of two variables, say x and y, then its partial derivatives are given by, and I'll add some notation to it here, say f sub x of x, y. This is saying I'm taking the derivative of f, the partial with respect to x, of f, which is a function of x and y, which is equal to the limit as h goes to 0 of f of x plus h, comma y minus f of x, y over h. Now, this y right here is telling you that y is a constant. You're fixing y. Y is some constant. So I'm taking the derivative with respect to x. So everything that's not an x is really, I'm thinking of as a constant. And likewise, we can say that the partial with respect to y of xy is equal to the limit as h goes to 0 of f of x, y plus h minus f of x, y divided by h. And again here, because I'm taking the derivative with respect to y, x is the value that I'm actually going to be fixing. Now there are several different types of notations that are used to represent partial derivatives. One of them I just used here, let me get the right color here. See, I want f x y. This is saying I have a function f of x and y, and I'm taking the partial with respect to x. And another way of writing this is simply the shorthand notation f sub x. But that can also be written as the partial of f with respect to x. And of course I can write that as the partial of, with respect to x, of f of x, y, which I could also commonly write as a partial of z with respect to x, and that's specifically for z being equal to this function of x and y. Now we use similar notation for the partial with respect to y. So the partial with respect to y of the function of x and y would be written like this, which is the very shorthand notation again is just simply f sub y. And that's the partial of f with respect to y, which is the partial with respect to y of f of x, y, which could also be written as the partial of z with respect to y, again for z equaling this particular function. So, there are a couple of more notations that you may run across, but this is the most common notation that's used for partial derivatives. So really, if you look at this, what this is really telling you is to find a partial derivative all you really need to do is to remember to treat one variable as a constant then take the, I'm going to say ordinary derivative with respect to the other variable. So if I'm taking the derivative with respect to x, I'm just going to treat y as if it were some constant and then take the derivative like I would normally take it. If I'm taking the partial with respect to y, I'm going to treat x like it was a constant and then take the derivative with respect to y just like I would normally do.